Now, another thing that we should also cover, that we're also going to cover in this segment, is what happens when we incorporate slicing into our arrays. And this is a concept that we introduced in week 5. Slicing is a way to get multiple adjacent values outside of a list. And in this case, we're going to take a look at how that applies itself to an array. And actually, before I do that, let's actually just go ahead and get a nice clean version of the array that we're actually going to be working with so we can focus on just that. So there's the array that we're going to be working with, printed out in a nice format of stacks, rows, and columns. And let's take a look at how slicing is applied to an array here. So just like before, we're interested in, by putting the 0 in here, you can see we have, we're just interested in stack number 0, which would be this assortment of numbers. This would be row number 0, which would be this 8, 9, and 5 here. And by putting the colon here, just a colon with nothing to the left and nothing to the right means I want everything in that dimension. So again, we talked about this in the week 5 unit, how if you have the brackets and then a colon, that just grabs everything. But since we're working with multiple dimensions here, this is not going to grab every single item inside of the array that we started with. It's only going to grab a specific assortment of items. So we're saying go into stack number 0, which again is this. Go look at row number 0, which is this. And then just the colon here means out of that row, I want every single column. So again, stack number, row number, column number. By putting just a colon here, that means grab every single column. So that I'll grab this assortment of numbers right here, this 8, 9, and 5. And by running that print statement, we can in fact confirm that is the result that we get back here. And if I want to, I could change this up a little bit. So now I've moved the colon over to the stack dimension. And by putting the colon to the stack dimension, I want every single stack. So it means every single one of these assortments of numbers. But out of all those stacks, I want the entry that's in row number 0, column number 0. And we take a look at that. That's just the number that appears in the top left-hand corner of every stack here. So again, row 0 would be this, column 0 would be that. So out of every stack, we want the number that appears in the top left-hand corner here, which corresponds to row 0 and column 0. So that would grab the 8, the 3, and the 2. Again, we're grabbing something out of every single stack. And if we want to, we can run this program and confirm that exact same result. And if we also want to, we can include 2 colons in here if we want. So now I'm saying out of every stack and out of every row, grab column number 0. So every single stack, every single row inside that stack, I want column number 0. So this would be this column from the first from stack number 0. This would be I should say column number 0 from stack number 0. This would be column number 0 from stack number 1, and this would be column number 0 from stack number 2. So it should grab these numbers right here. So every single row, just column number 0. And if we want to, we can confirm that to be the case. So you can see it did in fact grab 8, 12, and 13, 3, 10, and 21, 2, 11, and 20. Again, every single row, just taking column number 0 out of every single row that also appears in every single stack. And I could also make things a little bit more interesting, not by putting a 0 there. So if I only want a specific assortment of stacks, then I can also do that. So again, here's the original array that we started with. And remember, whenever I put the colon in here, whenever I put a slice in here, we're saying start at this number and go up to, but not including this number. Remember, this upper bound is not inclusive. So we're saying start at stack number 0 and then go up to, but not including stack number 2. So this would in fact grab stacks 0 and 1, not including stack number 2, which would be this sort of numbers right here. So we're only grabbing these 2 stacks. And out of those stacks of numbers, we want row 0, column 0, which again would be the numbers in the top left-hand corner here. You'll notice how I do in fact get those 2 numbers, and I've excluded stack number 2 by using this specific slice here. Excuse me, I excluded this stack. I only focused on these 2 stacks. So one thing that we should also notice also note, whenever you're going to perform a slice, you can actually preserve a dimension here. So this particular result, remember I was able to reproduce that specific result with this. By putting a slice in from one of the dimensions, you actually sort of preserve the dimensionality. If you put just a single number in here, then you actually lose a dimension. So when the case of in this specific case here, I just use a single number once, and since I started with something three-dimensional, by using a single number here, I lose a dimension. So I started with something three-dimensional, and then I ended up with something two-dimensional, which is in fact the result that we have here. And if we go back to what we started with at the very beginning, so here we use a single number once, so that drops us from 3 dimensions to 2 dimensions, and we use a single number again, which drops us from 2 dimensions to 1 dimension. But here we have just a colon here, so we don't drop a dimension. So we went from something three-dimensional to something one-dimensional, which again is the result that we get here. Again, we know it's one-dimensional because we only have one set of brackets at the beginning here. For some reason, it's highlighting the whole thing, just that one set of brackets. And in this case, we have something two-dimensional, hence the two sets of brackets at the very beginning and at the very end here. And another little tidbit that I'll also go ahead and mention, something you want to be kind of careful with, but this is also a possibility. You can actually, whenever you're using a slice, you can grab elements that are adjacent to each other. But if you want to grab elements that are not adjacent to each other, then you can specify which elements you want to grab by using sort of a Python list here. So this would be grab stacks 0 and 2. Get that entire, this actually is a Python list. That entire Python list takes the first dimension, which is the stack number or the stacks that we're interested in. So we're saying take stacks 0 and 2, and out of those two stacks, grab row 0 and column 0. So out of those two stacks, stacks 0 and stacks 2, we want row 0 and column 0 out of both of those stacks, which would be the 8 and the 2 here. And if we simply run that program, we can in fact confirm that result. So if you're having to deal with some sort of data that might be disjointed, this would be a situation where you would want to use that. But most of the time, just simple slicing is probably all you're going to need to use at any point in the future. But that's going to do it for this segment on this other segment on arrays. There's one more part that we're going to take a look at, which will talk a little bit more about how to do math between individual arrays, and that'll be a subject for the next segment. So with that, I will see you all in the next segment.